Hello and welcome to this episode. In this video, I'm going to try to explain to you the relationship between the CPU on your computer, the RAM, and something called bus lines. I mean, these are not too important for you to know, but they are very basic information that I think will help. And because I make the assumption that whoever is watching this course has no experience with programming in the past, I think it is very important for me to give an overview of how these components in the computer work together to ensure that your program gets run and then things work out exactly the way you intend for them to run. Okay, so if you open any computer system, and by that I mean the system unit, and unfortunately if it is a laptop, then you don't have anything or any unit dedicated as the system unit. Okay, if it was the old computers, then you have a separate unit we call the system unit. You have the monitor, you have the keyboard and mouse. But if you're on a laptop, then all these components are placed together, but the architecture still remains the same. So I just want to explain to you how these things work together, and then it will help you to understand how variable declarations, as I have showed you in the previous videos, work. Okay, so in every computer we have the CPU, which is commonly called the processor. Okay, so let's call this the CPU. Now, the CPU is the core part of the computer that executes instructions. That is the part that handles execution of all program instructions in your code. So, if you open a computer system, you see the CPU, and then we also have what is called the RAM. Okay, and the RAM is the memory, which also stands for random access memory. And this is the part of the computer where data is stored temporarily. And by temporarily, what I mean is that the RAM is volatile. So what it means is anytime the computer is shut down, whatever is stored in the RAM goes out. Okay, whatever is stored in the RAM is lost, because once the computer loses power, the RAM is not functioning. Okay, and there is another type of memory called the ROM, which stands for the read-only memory, and that is able to persist data between system restart. But this video is not about the ROM, so I'm not going to talk about it much here. Okay, but when it comes to execution of program, this is what happens. The source code, as you have seen in the previous videos, or whatever we define and then we store in a .py file, okay, our Python files will get loaded into our RAM, our memory, okay, and then the CPU is going to use special connections to the RAM, and these are called the bus lines. These are called the bus lines. They are in a computer system, and the CPU communicates with the RAM over the bus lines. Now, you may have heard that somebody's computer is a 32-bit computer, and then you may also have heard that someone has a computer that is a 64-bit computer. This 32-bit or 64-bit is actually a property of the bus lines, okay, and it determines the number of bus lines on which data is transferred between the CPU and the RAM. So if it is a 32-bit, then it means there are 32 lines bus connections between the RAM and the CPU. This is a rough overview. If it is a 64-bit, then it means there is a 64 bus connection between the RAM and the CPU and other important components of the computer. Now, whether it's 32 or 64 is important because it determines the maximum quantity of information that the processor is able to read from the RAM at once, or the maximum quantity of information or data that the CPU is able to transfer to the RAM. Okay, now if I have a Python file, so I'm going to draw my Python file here, and let's assume that this is our source code. Okay, so let's call this code.py. So let's say I have a file called code.py, which is supposed to be my source code. Now, if in the code I do something like age is equal to 15, and then I say score is equal to 98, what's going to happen is that these instructions, which makes up my source code, are going to be loaded into the RAM, into a special segment of the RAM. Okay, that is where my program instructions are going to be. Okay, so let's just use this shaded part to indicate the path of the RAM that stores your program instructions. So I'm going to draw an arrow here, and I'll say program instructions. Okay, now what will happen is that the processor also has internal registers. So inside the processor, we have some storage unit called registers, and these registers have specific functions within the processor. What happens during execution is that once the Python interpreter is invoked or instructed to execute what is in code.py, what happens is that these instructions are going to be loaded into a special segment of the RAM where the program instructions are stored. And then the CPU, using these bus lines, okay, using these bus lines, whether it's 32-bit or 64-bit, is going to read these instructions one by one, and then is going to execute them. Now, when the CPU or the processor encounters an instruction that has to do with the declaration of a variable, like you can see, let me label this as line 1 and then line 2. Okay, so once it fetches this line of code that says that age is equal to 15, what is going to happen is, let me try to zoom out the RAM. So I'm going to say I'm drawing the RAM again. So let's say this is the RAM, okay, and this is the part where our program instructions have been loaded. That is, the instructions in our source.py file have been loaded. Now, the processor is going to continue to read the instructions line by line. So this is line 1, this is line 2, as you can see in the diagram above. And what is going to happen is, once it encounters a variable declaration, like line 1 says age is equal to 15, what is going to happen is that the computer is going to reserve a space within the RAM that is fit to store 15 depending on the data type, and in a subsequent video I'm going to explain to you what data types are. But for now, I want you to be able to look at your source code and have a visual representation of what is going on within your computer when your program is running. I mean, the runtime of your program. So what is going to happen is that your computer is going to take this instruction. Let me change this color so I can highlight things differently. Okay, so once the computer encounters this code, I chose the wrong color. Anyway, I think it still works. So once the computer, let me undo this. So once the computer encounters this line of code here, the one highlighted in sky blue color, what is going to happen is that the computer is going to reserve a space in the RAM, and inside that space it is going to store the value 15. Okay, so it's going to place 15 here, and within the Python interpreter, this part of the computer, this part of the memory that stores 15 is going to be referred to as age. So let's say there's going to be something that points to this section of memory into what the Python interpreter internally uses to refer the variable age. Okay, and let's go to what happens when it encounters the second line of instruction. So once it gets to the second line, which is also a variable declaration and is the one I have highlighted in green, what is going to happen is that the computer is going to reserve a space in the RAM once again, and inside that space it is going to store the value 98. Okay, now once 98 has been placed in that portion of RAM, we need a way to be able to reference it in our code, because internally these sections of RAM, okay, are referenced by memory addresses. Okay, so this one will have a memory address. This one here has its memory address. And this also has its memory address. Okay, so each section of memory that stores some data has its own memory address, and these are usually hexadecimal numbers that are quite not easy for humans to remember. So what variable declarations in Python or within the Python interpreter or other programming languages does is that it helps us to use these human readable names to reference sections of our memory which otherwise would have been hexadecimal numbers. Okay, so this demonstration right here is supposed to help you to understand the basic relationship between the CPU in a computer, the RAM, and then the bus lines. Okay, now some of you may also have heard of late people talk about their CPUs or their processors being dual core. Okay, dual core or core i3, i5, i7, and so on and so forth. What this means is that within a single processor, there are multiple processing units within there that helps the computer to do what is called parallelism. That helps the computer to do multiple things at a time. Otherwise, what a computer does is not really doing multiple things at the same time. It is just the computer keeps switching between tasks, but because it is so fast, it might not be easy for you to realize that things are happening in sequence simultaneously as opposed to parallel. Okay, so there is a difference between concurrency and parallelism, and what helps programs to be parallel is the number of cores within the CPU. Okay, so if I have 3 cores within my CPU, then what it means is that at any point in time my computer can be running 3 parallel operations at the same time. Otherwise, if it is just a single processing unit within the CPU, then it means that the computer has to do what is called concurrent operations by switching between 2 tasks. But that is not the focus of this video. The whole idea here is to help you to be able to have a pictorial view of the code you write in your mind, and once you're able to make a mapping between your code and how it may look in your computer physically, then your understanding is much better. So thank you for watching, and I will see you in the next video.